IGCSE Computer Science, Syllabus Statement 1.3.3L, describe how sensors are used in real-life scenarios. So, the last video that we looked at was the sensors themselves. Now, you're going to have to watch that video before watching this one, because you're going to need to know about all the sensors before you go ahead and start using them. So, go ahead and do that, and once you're done with that, come back and we can get started. So, I said in the last video, I said something like, we need to be able to use sensors in the exam. They might ask us questions, they might give us a scenario where we have to describe how sensors in a microprocessor are used. Now this isn't like the other input devices that we learned. We looked at like digital cameras and keyboards and mice and stuff like that, and it was all theory that we had to just understand, memorize, pretty much. This is a bit different. This is where we have to learn about the sensors and know how to apply them in scenarios that the exam gives you. Now, we don't know what the exam is going to give us. It's going to give us something like, a greenhouse has a carbon dioxide supply and something like that. Describe how a microprocessor and a gas sensor could be used to control it. So we don't know what we're going to get. So we need to be able to look at scenarios where, we have to get into practicing how we can use microprocessors and sensors to control a system. So that's pretty much what we're going to do in this video. We're also going to do two examples and an exam question. So let's get to it. So this is the process of, the basic process of sensors in a microprocessor. So sensors send signals to a microprocessor or computer. Signals are converted into digital, if required, using an ADC. The microprocessor or computer checks the data received against stored values, and if the data received is outside a set range, that is the stored values, then, well, two things can happen. Now, it depends on what application is being used, or what system is being used. If it's a monitoring system, then a warning message or alarm is output. If it's a controlling system, then the computer or microprocessor will send signals to control actuators to deal with that problem. And of course, the signals might have to be put through a digital to analog converter, or DAC, in order for that to happen. So we'll look at a monitoring example and a controlling example in this video. Then we'll look at an exam question. There are sirens outside my house. Great. So let's look at a burglar alarm system, because I mentioned that with quite a few sensors in the last video. So here's how we could do it. So an infrared sensor senses movement of an intruder, or a sound sensor senses footsteps or breaking glass, or a pressure sensor senses the weight of an intruder, or all three, if you really want to. Anyway, this data is put through an analog to digital converter. Then this data is sent to the computer or microprocessor for it to interpret. The data is compared with stored values. If the data is out of range, the computer or microprocessor sends signals through a DAC, if necessary, to sound an alarm. Well, yeah, it's probably necessary, to sound an alarm or flash lights, or both. So that's pretty much how we have to structure our answers for a question that they give us in an exam. Like, I think that you get 1 mark for stating ADC or DAC. You get 1 mark for including the sensors, the microprocessor. So that's 3 marks. Comparing is another mark. And now the thing is, if they say a question is 5 marks in the exam, just know that they don't have an exact 5 points that you must include. It's quite open. Like, they'll have, say, 10 or 11 available marks for you, which you can include, and that'll be, basically there are a lot of marks available, even though it says it's worth 5 marks. You can still say a range of stuff and you can get full marks, if you get what I mean. I'm not really explaining it clearly, I don't think, but anyway, you get the point. Now, a street lighting system, for example, is a controlling system. So we'll see how that works. So a light sensor on a lamp sends data to a microprocessor through an ADC. The microprocessor checks this data against the stored value. So stored value could be something, I don't know, light units or whatever. Now, if the data is less than the stored value, then a signal is sent to the lamp through a DAC to turn it on. Turn the lamp on, that is. If the data is higher than or equal to the stored value, a signal is sent to the lamp through a DAC to turn it off. Now, there's one question in the 2015 paper which said, describe how how the system will deal with brief changes in the light, so like heavy cloud covers, that are really brief, or like rain or whatever. Well, this is what you could say. Number of minutes pass before another reading. So you could say 30 minutes pass, 10 minutes pass. And now what this does is basically, if there's a brief like cover of clouds and the microprocessor senses this change, so the lamp will have to turn on, then the cloud starts to, I don't know, disappear or something, and then reappear and disappear, reappear, or something like that. The lights, if it's constant checking, that is, then the light's just going to keep turning off, on, off, on, off, on, and that can be really annoying. So what the system can do is wait a few minutes before taking another reading so that the light stays on or off, and then can continue. And this is, of course, a cycle, because it'll keep happening. So here's an exam question. The conditions in a fish tank are being controlled using sensors and a microprocessor. To keep the fish healthy, the temperature must be at 25 degrees Celsius, and the oxygen content needs to be 20 parts per million. The tank contains a heater and an oxygen inlet controlled by a valve. A valve, of course, is the actuator. So this is what you could say. Now, there are actually two questions to where I found this. There's question A, name the two sensors used. Now, we could see here, sensor A and B. Well, we've got a heater and an oxygen supply, so obviously sensor A will be a temperature sensor, and sensor B will be an oxygen sensor. So, yeah. Now, I think that can give you a mark if you say gas sensor. I don't think that matters, but, still sort of gas oxygen thingy sensor. And then there's question B, describe how the sensors and the microprocessor are used to maintain the correct conditions in the fish tank. So here's how we could set out our answer. The temperature sensor and the O2 I should have subscripted that. Forgot to. It looks weird. So they send data to the microprocessor through an ADC. The microprocessor checks the received data against stored values, 25 degrees and 20 ppm, every 30 seconds. And if any of the two received values are out of their respective ranges, the microprocessor will send a signal to the heater or oxygen supply through a DAC to correct the error. Now, that should pretty much be, if it's a 5-mark question, then that should pretty much be the 5 marks, I think. If it's a bit less, then you can give an example, such as, you could say after this, for example, if the temperature is 26 degrees, the microprocessor will send a signal through the DAC to the heater, and will tell it to turn off for a while, wait another 30 seconds, and then if the temperature is, say, 23 degrees, then the microprocessor will send a signal to the heater to turn on, and yeah, pretty much that.